Hello, this is Kedilytics and welcome to today's session. In today's brief video, we are going to take a look at how we can be able to run a Cox proportional hazard model in STATA. So basically, we are going to describe or generate what we call the hazard ratios to be able to have an interpretation to them. So if you watch this video right to the very end, you will be equipped with the skill to be able to know how to run the Cox proportional hazard model in STATA. So we encourage you to stick and stay right to the very end. At the end of this video, you would learn a great deal. So please stay and enjoy it to the end. So first of all, we do set our STATA platform to the mode for survival analysis. And to be able to do that, we will do the save time failure. And then the outcome, which is good. ST set save time. Okay, there's a V here. All right. So now we interested in running the Cox proportional hazard ratio. So the code we need to be able to run the Cox proportional hazard ratio is ST Cox. And then here, unlike the normal regression model that we have to include the outcome variable as the first variable after the code, for regression analysis or the Cox proportional hazard ratio analysis, we don't need to select the dependent variable, but then it will automatically pick it. And so we are not going to set this and then we'll add the remaining. It's going to pick it automatically. So we just go ahead to add the independent variables of interest. So here we're interested in looking at sex, place of residence, and then we also want to see mother's education, which is edu. And then we are also interested in the wealth status of the household. We are also interested in the place of delivery. And we are also interested in mother's marital status. So with this, we also want the base level to be displayed. And so we are going to run this. Now, as I mentioned, getting to the end of the video, you are going to learn a very important thing. So we encourage you to stick and stay so that you can be able to learn that. So once we run the model, it takes a few minutes for it to get loaded. So as we can see here, we have our regression or our Cox proportional hazard ratio model being built. So we have the failure, this, and then the analysis time, which is step time. It gives us the iterations, and then we have the Cox regression ratio method for ties. So here we have the number of subject, number of failure, and then the total risk or time at risk. Then there are the person years, then the number of observations, the likelihood, then the p-value of the model. So here our model is not statistically significant, and so we don't want to use it for any inferential stats. But now when we look at the individual p-values here, you realize that's from edu for primary level of education is statistically significant. Now we want to talk about the hazard ratio, how we can be able to interpret it. And then we also talk a little about the confidence interval. So now generally, the interpretation of the hazard ratio is in relation to one or the reference. So we always do a hazard ratio when we're comparing two groups. So here we select one as the reference, and then so here male is the reference, and then the female is the one being compared. So generally, the hazard ratio is measured to compare the hazard rates or risk of experiencing an event between two groups. And so when we realize that the hazard ratio or the HR is 1, then it means that there is no difference in the hazard rates between the two individual groups, or so to speak, the risk of experiencing the event of interest in this case mortality of under 5 is the same over the two groups. Now, when it is greater than 1, then it means the rate is higher than the other group. And when it is lower, obviously, it means it is lower than the reference group. So in this case, we see that the hazard ratio is lower among females compared to males, but it is higher among the rural compared to the urban setting. And we can equally do same for all of this. But unfortunately, these p-values are not statistically significant. And so our references or inferences may not be statistical, may not make statistical meaning. And so we only fall for this. Now, you realize this hazard ratio is lower than this. So it means that there's less likelihood of dying among primary compared to those without. And this is statistically significant at the p-value of 0.038. So that we can say there's about 52% reduce hazards of death among this compared to among the primary compared to those without education. Generally, this is how we can be able to interpret that. Another key thing to take note of is the 95% confidence interval. Now, the 95% confidence interval helps us to associate the hazard ratio with a range of values within which the true hazard ratio is likely to fall. Now, it is important to note that if the confidence interval includes 1, then it suggests the hazard ratio is not statistically significant. So that's a very good clue. Now, when you look at this, you can see that from this range 0.6 to 1.5, 1 is in between, and so we have this p-value as not statistically significant. Now, when we look at this particular one, for instance, you realize that there's no 1 in between this because this is 0.2 and this is 0.9. So there's no 1. So 1 is not in between this. And so it gives us a clue that this is statistically significant. And when we come to the p-value, you realize that it is statistically significant. So in situations where you do not have the p-value and you have the confidence interval, you can equally draw conclusions based on that. Now, basically, this is how you can be able to run the Cox proportional hazard ratio using the STATA platform. If you find content such as this useful, we encourage you to continue to come to learn from us. And if you're new to the channel, hit the subscribe button and turn on the post notification bell so you are always notified whenever a new video like this is released.